The very first step is you want to write each side of your equation or each exponent in terms of the same base. So you're going to rewrite each exponent in terms of the same base. So when you look at these two exponents, you have a base of 9 and you have a base of 27. So you need to make adjustments to those. Is there any way to transform the number 27 into some exponent with a base of 9? No. So what you have to do is you have to find a common base. So what do you notice about 9? Is 9 a perfect power? 9 is what perfect power? 3 squared, right? So if you think of this as 3 squared to the x plus 1, so now you've changed that from a base of 9 to a base of 3. Can you do the same thing with 27? Is 27 a perfect power with a base of 3? 27 is 3 cubed. Okay, so there's your first step. You rewrite each exponent so it's written in terms of the same base. Once you get that step done, what you can then do is apply the properties of exponents. To simplify your expressions. Okay, so here the property is when you take a power to a power, what do you do with the powers? You multiply them, right? So we have our base of 3 to the 2 times x plus 1, and that's equal to 3 to the power of 3 times x minus 1. So here we're applying the property that when you take a power to a power, you multiply the powers. Okay, and then what you'll do as the final step, once you get your bases the same, all you need to do is equate the powers. And solve the resulting equation. Okay, so once you get it into this form, what you know is that this power and this power have to be the same if these whole values are the same, since their bases are already equal. When we equate the powers, we get 2 times the quantity x plus 1, 3 times the quantity x minus 1, distribute through. So we get 2x plus 2 is equal to 3x minus 3. And now solve the resulting equation. So if we subtract a 2x from both sides, we get x. Add 3 to both sides to isolate our variable, we get 5. And that would be our solution. All right, now there's a second way. So this is by hand. There's a second way to solve this, and that is by using your TI-89. Okay, Eric, question?
I had a question. When you did the minus 2x, why did you minus 2x plus 3?
So I subtracted 2x to move all the x's to the right side.
Oh, okay.
And then in the same step, I wanted to isolate my x's, so I moved all the constants to the left. And so the plus 3 was to get rid of this negative 3 here. All right, so the other step by using your TI-89 really involves just one step, and that is use the F2 algebra tab. Select solve, enter your equation, and that's it. So this is what my expectation is you guys will be doing for these. Again, if you want to do it by hand, you can, but I'll verify. If you hit the F2 algebra tab, choose solve, enter the equation exactly as it appears. 9 to the power of, make sure if your power has multiple terms that you enclose those in a grouping symbol. So x plus 1. Set that equal to 27 to the power of, in grouping symbols, x minus 1. Close it off and identify that x is what you want to solve for, so comma x. Close off the entire solve feature, and when you hit enter, it verifies that 5 is your correct answer.